Hi everyone! In this video, you are going to put your server to work by turning it into a web server. You will learn a lot from this video. I'll show you how to move files from your local machine to the virtual machine. Use SSH tunneling, find and kill zombie processes, and more. In this video, you will be deploying a full stack application that uses Vue.js in the frontend and FastAPI for the backend. The source code is available on GitHub, and I will make sure to put the link in the video description. I am using my personal website in order to show you the exact same steps I took to deploy it. The goal here is not to deploy my specific website on your server, but to use this project as a reference, especially if you don't have your own project. If you have your own app, but you don't use Vue.js and FastAPI, it's fine. You can adjust a few commands in this tutorial to make it work with your specific setup. Now let's go back to the slides because I want to show you the roadmap for this session. We will transfer the project to the server using the scp command. And I will show you how to organize the file permissions securely. Next, you will install the necessary runtimes. We will need Python for the backend and Node.js for the frontend. I'll show you how to set up swap memory. This is an important step for smaller servers in order to prevent out-of-memory crashes during the build process. We will use SSH Tunneling to securely preview the application on your local browser before opening it to the public. And finally, we will configure Uvicorn and Supervisor to make the backend robust and production ready. Now let's go to GitHub because we need to copy the source code. Click on the code button and copy this link. Now open your terminal. Since this is just a test, for me, I will put this in the download folder, but feel free to clone this repository in any directory. Run the git clone command and here paste that link that we copied and hit enter. As you can see, we are cloning the repository and the command finished. Great. Now we need to move inside this folder. So I will use the cd command and I will type in this name, and now I am inside that repository. And as you can see, we are on the master branch. Now let me type ls. I want to see what we have inside. As you can see, we have the backend folder and frontend folder. These are the two folders that contain the code for the website. The other stuff are not that important for now. These folders are inside my laptop. I need to move them to the server that we created on DigitalOcean. We could move them one by one, but that is slow and repetitive. Instead, we are going to compress these files and folders into one compressed file. In order to do that, we will use the tar command. So here I am going to call this compressed file source code, and we need to exclude some folders that are not important and that will take a lot of space. For example, the node modules contains the dependencies that the frontend needs. So we don't need this. We can generate it directly on the server. Same for Python. We have the virtual environment. We need to exclude that. We also have PyCache and the .git directory. So we don't need these folders. That's why we exclude them. And here we have a dot. And this means that we want to compress everything inside this directory. So if you wanted to compress just the backend folder, you need to change this dot and put backend or something else. But here we want to take everything and put it on the server. Now hit enter. And as you can see, we were able to compress everything inside this compressed file. Now we need to copy this from our laptop to the server. In order to do that, we are going to use the scp command, which stands for secure copy. And here, because we configured SSH alias in the previous chapter, we don't need to type the IP address of the server. We can just type in the name. So here I will take the source code. So I'm going to copy this and I'll put it on the website. And here we don't need to type the user at and then the IP address. We can just use the alias that we created before. And here I will put it inside the temp directory. Now hit enter. And as you can see, we have a progress bar that shows us that we are uploading this to the server and it's finished. So now I can go SSH to that website or to that server using this command. As you can see, I am in. Let's verify that we have that zipped file. And as you can see, we have it inside the temp directory. Now let's organize the project files. We should move this compressed file somewhere, but where exactly? The best practice for web applications is to use a neutral location like /var/www or a dedicated folder like web app. This approach keeps your application logic separate from your personal user files like .ssh or .bash history and prevents permission issues. So let's create this folder with the make directory command. So I'll use the make directory command and I'll put everything inside web app. Now we need to move the compressed file into this new folder. For that, we are going to use the move command. I will take the path to that compressed file and I will move it to web app. Great. Now we can, let's change directory. Let's move to web app. Let's type ls. And as you can see, we have that compressed file. Now we need to decompress it using the tar command again. And here is how we do that. Hit enter. And let's see. Yes, we have everything. Now we can delete this compressed file because we no longer need it. Let's type ls. Okay, great. So we have everything here. That's great. Now, before we continue, let's type ls-la and hit enter. Here you need to see that your user is owning these files. As you can see, my user is owning them. If you see root is owning these files and folders, make sure to run this command. Sudo chown, so change ownership, -r. We want to do this recursively. And here you put the user and the group. In my case, it's going to be AMAD. And here you specify the folder. But since we are inside web app, we need to change directory, or we can just use dot. Okay, and hopefully when you run ls-la, you'll be able to see that the ownership has changed and your user is owning these files. This is very important, so make sure to do that. Awesome, we are now ready to install dependencies. Let's start with the backend. First, we need to install Python tools because those are required for the backend. Here we are working with an Ubuntu machine, so this is how we can install them. So we are going to install pip, the virtual environment, and dev. And here -y will just accept everything and we don't need to confirm this operation. Awesome, we installed those tools. Now I'll clear the screen. Let's go inside the backend folder. And now let's create a virtual environment. So we will use Python 3 -m. We will use the VNV module and we will create a virtual environment called VNV. Hit enter. Okay, great. Let's activate the environment. So we will use source venv/bin/activate. If you see the name of the virtual environment here before your name, the user's name, that means that you activated the virtual environment successfully. Now, let's type ls because I want to see, we have the requirements.txt file. Those are all the dependencies that we need to launch the backend server. In order to install them, we will use pip install -r and we will provide the requirements.txt file. Let's wait for this to finish. And here, make sure that before you install the dependencies that your virtual environment is activated. because we want everything to be contained inside this project. Awesome, we were able to install everything. That's great. Let me clear the screen. And now we can start the backend to make sure that everything runs without any issue. And here we are working with a FastAPI application, which means that we need to use Uvicorn. This command or this library will be installed after running pip install -r requirements.txt. And here we have, so the entry point is inside this file, and the app is called app. We are going to provide 000 to the host because we want to make the server accessible outside the virtual machine. And finally, we want port, and let's use 8000 because this is what the front end expects. So now hit enter, and yeah, it seems to be working. If you see application startup complete, that means that you are in a good shape. And you can see that Uvicorn is running on this IP 000. And yeah, if you try to click on this link, nothing will happen because let's see, let me show you. As you can see, nothing happens because this server is running inside the virtual machine. It's not running locally on our computer. Close the page, go back to the VM. But if we can't access the server outside of the VM, how can we test it? Well, in order to test it, we need to open another terminal. I will use, again, the SSH command, and I will go inside the VM. But before I test it, I want you to run the ufw status command, provide your password, and I want you to make sure that the firewall is active and that you have just SSH. So these are the ports that are allowed. But we don't have port 8000 or other ports. That's why we were not able to access this server outside of the VM. But we can at least test using the curl command. So we are going to send a request to the server. And here 127.001 means localhost, basically inside the VM, inside the server, and 8000 is the port. And this is going to make a GET request to the server running on this port. So yeah, let's see what we'll get. So it says detail not found. Maybe because we need to do health. Let me go inside the web application, backend, and let's look at the main file. Let's use, maybe nano main.py. Let me make the screen smaller. I want to see the endpoints that we have here. So yeah, we need to use /API/health in order to get status is okay. Okay, let's zoom in again. And here we need to, before health, we need to add API. And as you can see, we get status is okay, which means that the backend server is responding. And if you look at the logs, you see that we were making GET requests. We were getting 404 because the endpoints didn't exist. So the root endpoints or the /health endpoints don't exist. That's why we got 404. But when we try to talk to this endpoint, API/health, we got 200 okay because it exists in the source code. Great. So this confirms that the backend server is running and that we installed all the dependencies that we need. Hit Control-C because we want to stop the server. We no longer need it. Now we will move to the front end. We are going to install the dependencies there and do the same thing. We need to verify that it works, and after that we will combine them together. You can see that we are inside the backend folder. Let's move one layer up. We have the virtual environment is still active. We can leave it like that, or if you want, you can type deactivate like so. And now we need to go inside the front end folder. I'm using Vue.js in the front end. This means that we need to install Node.js. And the best way to install Node.js is with nvm. If you don't know, npm is a Node package manager. So just type npm GitHub. There it is. And the installation is easy. You just run this curl command. So copy it, go back to the server and paste it here. So this is the latest version of npm. Now, in order to install it, as I said, we just hit enter and voila, it's done. Now, the problem is that when you install npm, you need to create a new terminal to basically get the command, because now if I run npm, you can see that it's not recognized. But we have a solution. We can use source. And here I am using bash, so I'll target bash rc. And this, so when you run this, it's going to basically load in npm. So now if I type npm, you can see that it works. And let's verify that the version is correct. Yes, it's 040.4. Awesome. Now we need to install the latest long-term support version of Node. And in order to do that, we run npm install, and we provide LTS because that's what we want to install. And this is the latest LTS version from Node. And if you want to verify if that's correct, you can go to nodejs.org, click on get Node.js, and as you can see, so the latest LTS version is 24.13.1. Let's verify that, and yeah, that's correct. So 24.13.1. We also need to install pnpm. This is the command that I use to install the frontend dependencies. I don't use npm, and this is how you install that. Make sure to install the latest version of pnpm, version 10, and not prior ones. Hit enter, and here we want to install it globally. Okay, so it's working. It says that there is a new minor version of npm available. That's not important. So let's skip that. And now let's verify. We are inside the frontend directory. Type pnpm install and hit enter. And as you can see, yeah, pnpm is very fast, and it's I really like to work with it. And voila, we have everything installed. And now in the front, so when working with Vue.js or any front-end framework, you need to run the build command to ensure that everything builds. So let's do that. And here we are going to hit a out of memory problem. So this is why we need to create a swap memory. But let's verify if that's what will happen or not. Okay, so as you can see, the terminal is stuck, but let's wait a minute. If you want, you can also go back to the other terminal and maybe run Btop. But as you can see, the VM is struggling, so I can't run things smoothly, and that means that I'm running out of memory. And yeah, this command will fail at any second, so let's just wait. Yeah, so this one is stuck. Let's go back to here and let's wait. I am back to the other terminal, and as you can see, the memory is full, and this is not updating because it's struggling. And as I told you, the command failed, and that's because we don't have enough memory to build the front end. Is that the end? We have a solution. So when on Linux, we have something called swap memory. Basically, we take some portion from the SSD and we use that as additional RAM. It's going to be slower, but it's going to help us deal with these situations where we run out of memory. Let's run the df command. It's going to show you so all available, and yeah, let's type -h to make it human readable. As you can see here, we have 8 GB of disk storage and we have 5 GB available. I'm going to take 2 GB from this partition and I'm going to create a swap file because we don't need all this storage to run the frontend and backend. And this is how we create a swap file. So we use the allocate command. We specify the size, and this is the file that we are going to create. And here, so let's just run the command first. Let me provide my password. it worked and we didn't get any error. That's great. And I want to explain something. So when you see /swap file, this doesn't mean that this is a folder. No, it's a single file acting as a virtual RAM. So this means that you can't do this. You can do this. Let's type in /la, and as you can see, it's a file. If it said D, that means that it's a directory. But yeah, it is a file, and it's owned by root. Why did we create a file instead of a dedicated disk partition? Because we can easily resize or delete this file if we wanted to, if we don't need it anymore. This is the flexibility of working with files. But we need to set up some permissions. Again, let me type in ls-la. You can see that these are the permissions. We need to change them. And to do that, we are going to use sudo chmod 600 and swap file. I'll explain what the 600 means. Now, if I type ls-la, you can see that some of these characters have changed. So W means write, R means read, and X means execute, but here we don't have X. And the first three, let's say, letters are relative to the root user. The second three are relative to the second three are here for your user. So in my case, it's Imad, and the last ones are for other users. So here, so we did 600, which means that root will be able to read from swap file and write to it, but the other users are not able to touch this at all. So we created the swap file. Now we need to make this file as a swap space. And to do that, we are going to use the make swap command, and we are going to provide that file. Hit enter. And as you can see, it says setting up swap space, and here is the size. And it gives us an ID, which is not important. Now let's enable it. So we created the swap space. Now we will use swap on and swap file. Hit enter. How do we verify this? We are going to use the swap on command, and let's type show. And yeah, we have it here. So this is the file name, and this is the size. It says that the type is file. That's good. And here we have priority. The priority level is set to -2. In our case, it doesn't matter because this is used only when we have multiple swap files. So if we had another swap file that had a lower priority level, then Linux will prioritize this one, and when it's filled, it's going to move to the other one. But in our case, it's not relevant because we have just one swap file. By default, this swap configuration will be lost when the server reboots. To ensure that the swap file loads automatically every time the system starts, you must add it to the fstab file. Let me show you the fstab file that I'm talking about. It's this one. Now let's try to, let's see the content. Okay, so this is what we have. And we are going to, put this string inside there. And we are going to use one command to do that, to make things quicker. Here we have echo. It's going to split this string. We use the pipe command to take the output from this command and give it as input to the T command. Let's hit enter. Okay, great. So it worked. Let's go back. And as you can see, we appended this string to the end of the fstab command. Now that we have added extra memory, let's try to build the project again. So let's run pnpm run build. I will also, let's open another terminal and let's go SSH to the server. And here I want to run htop. Okay, and as you can see, htop also detects the swap memory. So currently it is empty, but look what will happen when we start the build process. Let's see what will happen. As you can see, we are already filling the swap space, and look how the physical RAM is quickly filling up. Nothing is freezing. That means that it works. So if you look at the total space consumed, it's greater than the total memory that we have inside this machine. And it seems that it worked. Yeah, it built. So yeah, that's awesome. Before making this tutorial, sometimes Node was not using a lot of memory, so the build failed due to an error called heap limit error. If that somehow happens to you, then before running pnpm run build, you need to pass this variable. So here we are going to set max all space size to 2 gigabytes. We do that before starting pnpm. In my case, it worked, but if for some reason, again, you get that heap limit error, you can solve that by using this command. Awesome, so we built the project, and as you can see, we have the dist folder. It contains everything we have in the front end. Let's move inside that directory, cd dist. Let's see, we should have, yeah, we have our assets there. We have the index.html, some images, sitemap, and stuff like that. Now we can create a temporary Python web server on port 8000. Let me use Python, and we want to use this module, http.server, and the port is going to be 8080. I need to use Python 3. Okay, great. So we are serving the build files on this port. Again, we cannot access this. So if you try to open this on your local machine, it's not going to work because the firewall is active and we are not letting traffic through this port. But are we done? Maybe, yeah, we can use the curl command if we want. So we can do something like this. But yeah, we have port 8080 this time. And as you can see, we get some HTML back. So that means that it's working, right? But we want to see this. We want to see the UI because the backend. It's fine if we run curl commands on the backend, but when it comes to the front end, we need to see it with our eyes to validate that it is working. But you might say, well, we cannot do that because the firewall is active. But I have a solution for you, and it's called SSH Tunneling. Let's go back to the slides because I want you to learn about this amazing feature. Okay, here we are, and let's look at SSH Tunneling. I have this diagram that I made in order to explain this concept for you. We have our laptop is sitting here. It can be running maybe Linux, Mac, or Windows, it doesn't matter. We have the SSH key pairs that we created. Here we have the private key, and we will be accessing the website through a browser. And here on the other side, we have the server. It can be running on DigitalOcean, Azure, GCP, AWS, doesn't matter. We will have our front end running here. In our case, it's Vue.js, but it can also be React, Nuxt, or any other framework, or just pure HTML, CSS, and JavaScript. And we have our public key. In the middle, we have a tunnel that we call SSH Tunnel. How do we see the app without opening, let's say, port 8080? We use SSH Tunneling for that. Think of this as a secure private subway line that runs inside your existing SSH connection. We don't need to change the firewall because we are already allowed to access the server via SSH. To create a tunnel, we use the -l flag, and this syntax tells SSH to bind port 8080 on your laptop, it's this one colored in pink, to port 8080 on the server. After running this command, a tunnel will be created. Now, if I open my browser and type localhost and specify port 8080 in my browser, the request is not going to stay on my computer. It's going to travel through the tunnel. It's going to reach the server, and here it's going to reach the server on this port 8080 because this is what we specified here. It's going to see that we have a server running. This is why we have, we ran that Python command to create a temporary server. Okay, so it's going to forward that to the front end. The front end will respond with that HTML. It's going to go back through the tunnel. It's going to hit the browser, and the browser sees HTML, it's going to load it. So this is the concept of SSH tunneling, and it's really great. And as you can see, we didn't update the firewall configuration to allow port 8080. It is enabled directly because we are already using SSH. But if we stop this command, the tunnel will go away, and these ports are not going to be connected. Awesome. So yeah, let's do this. Let's create. So here I'm already inside the machine. I need to exit by using Control D or exit. And now, yeah, let's write that command. So it's SSH-L. Let's type the local port on my machine. Here we need to specify localhost 8080, and let's use my alias, my website. As you can see, we are inside, and now we have a tunnel. Let's go back. You can see that we have the server running. Now let's open Firefox. And now we can go to localhost 8080. And voila, as you can see, it works. You saw that we got some errors because we are making requests to the backend, but we don't have a backend running. So you can see that if I go to the blogs page, nothing will show up because we don't have the backend running yet. But that's not a problem. What we wanted to see is basically the UI. Does it look right? Did we load the images? Is the font loaded? Do we have animations running? Stuff like that. This is what we wanted to verify. But connecting the front end to the back end or to other services should be easily done when we connect it to the back end. Awesome. And yeah, let's go back. Now, what will happen if I do this? So let's close this. Now we have no SSH tunnel. Let's go back and let's refresh. You can see that it doesn't work because now the two machines are not connected. Great, so everything is working perfectly. Nice. We installed the Python, the backend and frontend dependencies. We made sure that both servers run correctly. Everything worked really well. Now we need to move to installing Gunicorn and Supervisor. But why do we need them? Let's go back to the slides again to explain this. Here is the diagram that I created for this slide in order to explain this. As you can see, we have three components. We have Supervisor, Gunicorn, and Uvicorn. We have used the Uvicorn command to run the Python server. After that, we used curl to ensure that the backend responds correctly. So that's done, but we did this manually. What will happen if the server crashes? We need to, again, SSH to the server and run the UV command again. Is this scalable? No. What will happen if your server crashes at 4 a.m. or something? Are you going to wait until 8 a.m. when you wake up and launch it? No, we want the system. We want the server to do this for us automatically. And this is why we need these three components or this architecture. At the bottom, we have our workers. The worker is Uvicorn. The worker is going to run your FastAPI code. So if someone visits the website and wants to get blogs, the worker will get that request. It's going to talk to Melisearch and it's going to get the response and send it back to the user. Or let's say that someone wanted to maybe do a search query or maybe like a blog. That worker will also do that. And let's say that we had a huge traffic. Let's say that we have maybe 100 people trying to access the server at the same time. Then the load is going to be balanced through these workers. Here, let's say that we have 3 workers. So this one is going to get maybe 33 requests. The other one is going to get 40 and the other one gets 30. So yeah, and Gunicorn will do that. It's going to balance the load through all these workers. Now, we know the role of Uvicorn, but why do we need Gunicorn? Gunicorn acts as the manager. It spawns multiple Uvicorn workers, and this can be configured. So if you want to have just one Uvicorn instance or worker, you can do that. If you want to have 3 or 10 or whatever, yeah, you can do that. You can just change the configuration. We will see this after explaining this slide. Let's say that this worker crashed for some reason. Gunicorn will detect that. It's going to delete it and replace it with a new worker. And this is going to be done automatically for you. You don't need to enter to SSH to the server and start the worker manually. That's not scalable, but this is. Above that, we have the supervisor, or we can also call it watchdog. In engineering, this term means a hardware component that basically will hit the reset button if the system freezes for some reason. Let's say that something bad is happening, Gunicorn is not doing good, the Uvicorn workers are also crashing. Supervisor will detect that and hit the reset button, which means that we are going to recreate everything from scratch, just to ensure that the application is healthy again and is ready to receive requests from users. So yeah, this is why we need Gunicorn and Uvicorn and also supervisor. And you saw we tested manually. Always do that. Try to test your application manually by running the commands like what we did. So we ran Uvicorn to start the backend server. After that, we moved to the front-end server. After validating that, we can automate this process. Let's go back to the server and let's do this. Okay, now let's stop the temporary front-end server because we don't need it. Let's also go back to backend, activate the environment, and let's install Gunicorn. I'm not sure if I already have it in the requirements file. Let's just double check. And yes, we have it. So yeah, that's great. So we don't need to install it separately. Let's make sure that it is there. Yeah, it is there. So we just didn't receive any application. So that's fine. So we have Gunicorn and we also have Uvicorn. Now let's try, we need to create a Gunicorn start script that will tell Gunicorn how to run your application. Let's call it Gunicorn start and let's use nano. I'll paste all this directly here, but don't worry, you should be able to find this on my blog. Yeah, I'll make sure to deploy it in the future. So if you go to blogs, you'll be able to see the individual articles here. So if you want to copy paste them quickly, you can do that. Don't worry about it. Or you can go to GitHub. I have this repository where I basically document these videos in a in text format. So we have foundation. So now we are in chapter 2. So you can click here and you will find everything here. So you can just copy the commands and paste them in your VM. So okay, let's continue. We forgot to add the shebang. So let's add it. We are going to use bash. We have some placeholders that we need to change. Let's start with the user. So my user is Imad and the group is also Imad. So let's provide that. We have the number of workers. Let's set it to 1 because we don't have a lot of traffic and we are just testing. So as you can see, I have this comment, increase this if you have more traffic or a more complex application. But when you increase the number of workers, you will consume more RAM. So keep that in mind. The application directory is web app backend, that's correct. And we have this socket file. We'll come back to this later. And here we need to give the project a name. Let's call it my website or something, or a Imad website. And here the worker is going to be Uvicorn. That's fine. Here forward allow IPs. Yeah, so here we just want to pass the IP of the user directly because we will talk about Nginx and Unix sockets later. So don't worry about this. Here we are just showing that we are starting this website. We move to the directory. We activate the environment. Here we create the socket file. Let's go back to sock file. We need to create this. So this is important because it's going to communicate with Nginx. But we will talk about this later. Don't worry about it. And here start Junicorn. So here we have the execute command. Junicorn is inside the virtual environment. We could have just, since we activated the environment, we could just type Junicorn, that's fine. The application is inside the main file, and we pass these arguments. So the name of the project, the number of workers, the worker class, which is Uvicorn, here it is, timeout, the user and the group. We bind this to the socket file, we forward the IPs, and we have some login. Great, so now save this. I'll hit Control S and then Control X. And now we need to make this executable. So let's do sudo chmod plus X. Or before that, I want you to understand the chmod command. So before that, let's run ls-la junicorn start. You can see it's not executable, but if I run chmod plus X unicorn start and run the ls-la, you can see now we have X, and X is available in the 3 users. So root can execute this file, my user Imad can execute this file, and other users can do the same. Great, and you can see that I am the owner of this file. So we configured Junicorn. Now we need to configure supervisor. We could run this script manually, but if for some reason Junicorn crashes, we need to come back and rerun it again. We don't want to do that. We want supervisor to do this for us. Supervisor is not installed by default. Yeah, it's not recognized, but we can install it using the up command. So let's do that. Supervisor. Let me provide my password, and it is installing. Great. Let's wait a little bit. Let's also create the logs folder, because we want supervisor to save logs there, so that we can, if something bad happens, we can see what happened there. So that's important. And again, verify that you are owning that directory. So run this, and yeah, we are running that. Since we don't use the sudo command, we will be owning everything. But just in case, it's a good practice to keep checking the ownership. In order to configure supervisor, we need to create this configuration file. So supervisor lives inside the etc folder, and here we want to create our own configuration. And let me paste this. Okay, so as you can see, we want supervisor to run the junicorn start command. So the only thing we need to change here is the user. It's going to be Imad, and here we need to change this placeholder. Let's call it Imad website. Okay, and the log file, we are going to store to store logs inside this. This is why we created this directory. And yeah, save this, hit Control X. Great, now we can start this service. Let's use sudo supervisor ctl, and here we are going to reread the new configuration. It says available, the text is this new config that we created, and now we need to, let's run this. Great, so we added this to the process group. And now let's check the status. It should be running. So if I type status, and here you need to type that project name. Great, it says running, it didn't crash. That's great. Let's see, so we have logs. So let's look at logs, supervisor log. The file exists, awesome. Let's do cat or maybe tail. Awesome, so it's working. You can see that, let me look at the full output. So this is just configuration. Yeah, great. And here the application started. So we are starting Junicorn. It's listening at this socket, and here we have just one worker, and the application startup complete. So this means that it's working. We can try and yeah, let's do some curl commands. Oops, we don't have it here. That's fine. Okay, this is the curl command that we used earlier. Let's try to run it, and it failed. It says failed to connect to localhost. Why this command failed? We have tested this before and it worked fine. Let me show you why this fails. Remember, we have, let's look at the Gunicorn start file. You can see that we are using this socket file. So in order to communicate with the server, we need to use the socket file that was created here in backend. Let's verify that it is there. Yeah, as you can see, we have Gunicorn stock, and if I look at it, yeah, it's a different type of files. In Linux, you can see that it has S, which means socket, and this is used, it's like a pipe. It's used to by different applications to communicate with each other. In our case, we want the backend server to communicate with Nginx, but we don't have Nginx yet. We are just preparing for that step. But to fix that, we can do this. So with curl, we can specify the Unix socket file, and here is the socket file that we want to use. And same here, we are going to use this endpoint. And curl will use this socket as a way to talk to the backend server. And the backend server will send the response through the socket to curl, and curl will display that. As you can see, I ran that and I got status okay. Awesome. Now we can run tail again just to verify, and yeah, we got this. So this is the GET request. We got 200 okay, and yeah, it took less than 2 milliseconds. Awesome. So yeah, everything is working. Now, if we run Btop, or I want you to install this. So we have a replacement. We have many applications like Btop with good UI. One of them is called Btop, and I really like Btop. It looks like, yeah, this is a Btop, and it's available on a lot of Linux distros. It's also available on Ubuntu, so that's great. And to install it, we can, as you can see, it looks really, really nice. So we are going to use this in order to monitor the processes, memory usage, etc. And to install it, we can run the apt command, sudo apt install Btop. Awesome, now run Btop, and as you can see, it looks really nice. So here we have the CPU usage, you have memory usage. Let me decrease the font size. Okay, so we have 8 gigabytes of storage. We are using 65%. This is the swap space that we created. It's not used, so we are just using 6%. This is the available memory. It's almost 500 megabytes. We are using 35% of the memory. And yeah, we have also the network. So we have the download and upload speeds. And here we have the processes. This is what we care about. And here you have filter. With the arrow keys, you can, let's go to memory, because that's what we want. And this is going to sort everything by memory. If you want, you can hit R to reverse this, but we want this sorted in a descending order. And here, type filter and run and type Gunicorn. Why? We want to see the processes that are running. Here we have just one worker, but you can see that we have 2 processes. Why is that? So one Gunicorn creates 2 services. So one will manage the workers. So one of them is the worker, and the other one is the one controlling those workers. And as you can see, they are using roughly 24 megabytes. That's not a lot, because the application is not doing anything right now. But this is why I mentioned that if you increase the number of workers, you are going to consume more memory. Why I installed Btop? Because I want you to learn about zombie processes. This is something very important, because sometimes this happened to me. I didn't pay attention, and my memory usage was rising up quickly because I was not restarting Gunicorn correctly. Because sometimes when I work on a new feature, I push that to the server and restart the backend. That created zombie processes. Basically, some Gunicorn processes were left here. They weren't doing work, but they were consuming memory because they were from the old deployments. So let's see. We don't have this problem right now. We have just created this, but I will try to do to basically create zombie processes just to show you how this looks like and how to deal with this problem. But first we need to go and SSH to the website. Great. So if you don't want to look at this, we can run this command ps-aux, and we are going to grep, and we are going to use, I think, imad websites. We have two of them. So yeah, this one and the other one. This looks ugly because we have a lot of text, but no problem. It's confirmed that we have two processes running. Now let's first go to web app, backend, and I want to run this manually just to create more processes. Let's do this. So Gunicorn. Now hit enter. This is going to create, this is going to run again the backend, and it's going to create more processes. Let's wait a little bit. So you can see that the memory usage is getting higher and higher every single time. Okay, good. And now if we want to, we can also go inside that file, Gunicorn start, and let's change this from 1 to 3, save, exit, and now we need to restart. We will run this command. Because we changed the configuration, we need to read that and restart again. Let's do this. So restart, and let's use my project name. I need to pass my password. Okay, it says stopped. Let's look at this. Okay, so the old processes were gone, and now we have 3 new ones. We should have just the manager is going to be controlling the workers, and we should have 3 workers because this is the new configuration that we created. But we also have how many? So we have 1, 2, 3, 4, but we have 3 orphaned processes, or we can also call them zombie processes, that are consuming memory but not doing any useful work. And if you get this somehow, this is how you solve this issue. You can't just come here and hit K to kill the process, because it's not clear which one is doing work. I mean, you can sort of get that information by looking at the memory, because the workers that are busy are going to be using more memory. But yeah, you need to confirm this, and I'll show you how to do that. Let's run ps-aux. As you can see, we have plenty of processes. Great. Now I have this command that we can run. It's basically giving us the same info that we have here in Btop. I'm just showing you that running commands like these, it's not that fun, but looking at this in a terminal app is really useful, and it's fast. But you can do the same thing with just Linux commands. And here are the processes and how much memory they are using. We can also try to sum the memory. So we are using almost 300 megabytes. But yeah, we have some processes that we need to remove to free some memory. So the quick fix is to kill all Gunicorn processes. And to do that, you can do it here by hitting K, and you say, yes, I want to kill this. But if you want to kill everything, you can use process kill, and this is the name of the process. But this will cause downtime. Your application, your users won't be able to access your application. The frontend will try to make requests to the backend, but it's not going to respond, so they will get errors. So this is the easiest. You do this, and then supervisor will start everything up because it sees that something bad happened. Where are the Gunicorn services? It's going to panic, but it's going to run them. Let's actually do it. So let's look at this. So we have all these Gunicorn services. Let's kill them. Now let's go back here. You can see they are gone, but supervisor created them quickly. You can see that we have 4. That's the correct amount. We have the manager. One of them is the manager, and the other ones are workers. And you can see this is why we used supervisor in order to solve this issue for us. Great. Yeah, this is the easiest solution and the quickest. But it will cause some downtime, but yeah, it depends on your application. If you don't have a lot of users, just do this one, it's fine. But if you have more users, then yeah, we shouldn't do it. Let me show you the other option. So I will again run the Gunicorn start command. Okay, we created more processes. Let's restart. Okay, so you can see that the restart command is the one that's causing the issue. It reads the new configuration, but it doesn't delete the old processes. It just creates new ones. So this is the big issue that we need to solve. And this is what I was doing in my websites running currently on production. I was just pushing new changes and I run restart before removing the old ones. And this created a lot of orphaned processes. So you can see that now we need to remove 3 more processes. Okay, I have showed you the easy method. Now let's try to solve this surgically without causing any downtime. First, we need to ask supervisor for the process ID of the Gunicorn process, which we can also call master because it is controlling the other workers. And to do that, we use sudo supervisorctl PID, and here you type your project name. So this is the PID of the master process. This is very important. In your case, it's not going to be the same. It's going to be a number, but just remember it. Now let's look at the process hierarchy. We can use this command. Okay, so yeah, we have a lot of text. We can also do the same thing here in Btop. You can see that you have this tree column. Just hit E, and as you can see, it groups everything. So this is the master process. You can see that it is controlling these 3 processes, and these ones, they don't have a parent. So they are just here. They are orphaned processes that are consuming a lot of memory, but doing no work. So we need to kill them. So now this makes it easy. So I can just hit K and kill them one by one. But we can also see this in the ps-ef command. Yeah, I know this is a lot of text. So let me just copy this and let me open a text editor. So I'll open them in VS Code. So yeah, this stuff is not needed. So you can see that these are all the commands that we are using in order to run the Gunicorn service. We don't want them, so let's just delete this stuff. We don't need this too. And this. Okay, great. Let's zoom in a little bit on this part. Okay, great. So let me also go back to the terminal. Let me also copy the master ID. So this is the master process ID. It's this one. You can see that how many we have. 3 of we have 1, 2, 3, 4, 5, 6, 7, and 8. Where is the manager? Here is the manager. So and here I forgot to add the column names. I think let me go back. I just want to confirm something. Let's go here. This is the process ID. This is the parent process ID. RSS, yeah, we don't need this one, so let's remove it. We just want these 2. Let's see. We have these are the 3 Uvicorn workers, and they are attached to this master process ID. And if we look at this, it's going to point out to this one. And this is that 4th Gunicorn service. This is the same as this. We have these. So let me double click on this one. As you can see, here is the process ID. It's 531402. 531402, and it is attached to the parent. Let's look at the parent. Yes, it's this one, 531399. This is your group. It's exactly this. You have one process ID, one master process and their children, but we have these 3 strugglers, these 3 orphaned processes. They are these ones. So 274, 272, and 273. Here they are. And the PPID is equal to 1. What does this mean? In Linux, PID 1 is the system init process. This means these processes lost their parent, but at least they were adopted by the init process because they need to be attached to something. This is how you detect orphaned processes. If they are not attached to a process ID, if they lost their parent, they will be attached to init. And now we can simply delete these. And we have their process IDs, so we can do it here with the help of Btop. Let's do it once for this one. So we hit K and yes. And it should, yeah, it's gone. Bye. We no longer have that zombie process, but we have the other two. If you want to do this with the terminal, you can just use sudo kill, and here you provide the IP addresses or the process ID, sorry. You pass them like this, one after the other. Now hit enter, go to Btop, and they are gone, and we freed memory. You can see that we had to do a lot of stuff in order to detect the processes that are not used by our backend, but this is useful if you don't want to cause any downtime at all. Your application code is on the server. We built it, we run it, and everything went smooth. The backend is managed by Supervisor and listening on a private socket file. However, no one from the outside world can access your application yet. This is a problem that we will fix in the next subchapter. We are going to talk about Nginx, security headers, and stuff like that. See you in the next episode.